Okay, welcome everybody. Does anybody have any questions? Any questions? Okay, remember to when you have a question in class, just to raise your hand and someone will come and help you. And if you have a question during the week, send your first question to the TA, and if they don't have the answer, then they'll tell you to contact me, or you can just contact me, but first contact them. Okay, let's see. Okay, so this is lecture 5. It's called VB Decision Structures. So if you remember when we looked at the flow chart, remember what a flow chart is? Remember that? Boxes and diamonds and stuff like that? Remember that? The diamond shapes, they also referred to as decision nodes, I think. So it's the same thing. I mean, we're going to be talking about a similar thing today. Decision structure is basically, you know, what is it? I guess what is it when you make a decision? Say, I'm going to do this because of that, or something like that, right? Because of a certain set of conditions, I'm going to do a certain thing, right? I guess that's what a decision is. So anyway, in computer programming, we're talking about if, then, usually, or some kind of form of that. Okay, so we also have if, then, else. Okay, so if this, then that, otherwise something else. Okay, we have those kinds of structure, that kind of programming statement. And that's what we're talking about today. And there's one little variation of that as well, but that's basically what we want to talk about. That's obviously really important in programming, right? Because you want your programs to do one thing, you know, based on something that happens. The user clicks one way, or the user clicks another way, or something. A number is greater than something, then you want one thing to happen. A number is less than something, you want something else to happen. So those are like. So here we have, if the score is greater than 60, then we want something to happen. The student passes. And then we can say, otherwise, if the score is less than 60, maybe the student fails. Something like that. So that's we run into this kind of structure all the time. If the number is greater than, then do this, else do that, that kind of stuff. And so this is a little bit off topic, but we can also have what are called nested if statements. So they're also called embedded if statements. So here we have something like if something, then something else, and then we have else, and then we start a new if statement inside the else part. So that's called a nested if statement. So this part is this if statement is kind of nested inside the whole larger if statement. And then you have to worry about the parentheses. Anyway, we won't talk about that now. Let you know in advance. You can also do things like, you can also do something like this. If something, then something else. Else, you could also have like an if inside the else statement. Okay, so you can have else, if something, then do this, else do that. So you can get this kind of, we call it nested if statements. I don't know if we'll see that today actually, but that's a very common thing to want to do. You can imagine, I'm sure you can imagine a situation where you'd want to employ something like that. If today is Monday, then we have computer class. Else, if today is something else, then something else, right? So you could do that, right? And you could have actually multiple embedded or nested if statements. But anyway, I don't think we do that today. Okay, but certainly you might want to do that. And you can do that. Okay, all right, so let's look at the outline first. In this lecture, we will discuss Visual Basic decision structures. So that just means decision statements or decision code, or how to implement decision code. The if statement allows multiple choices with else and also else if. I don't think we use else if today, but you also have else if. They're just another variation. And nested if statements. Okay, I just mentioned that. And then, we'd like to be able to use these kinds of symbols, like this one. What is this? How do we read this? Greater than or equal to, right? So, of course, you want to say, like, if my weight is greater than or equal to blah, 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 then one thing. And if it's something else, then it's something else. Or if, the person earns this much money, then that, or something. So you want to use this kind of, they call comparison operator, just greater than sign, in other words, or less than sign, or greater than equals sign. Often, we often would want to use that. So we have these so-called comparison operators. This is another one. This means, this is just the not equal sign. This is how they write not equals, okay? It's not very hard, just a little unusual. And this is equals. Now, actually, I think in an earlier class, I said that equals is this symbol. And actually, I forgot. In Visual Basic, that's not true. In almost every other language, that is true. But in VisualBasic.net, they just use the regular equal sign. That's a little bit weird because that same equal sign is used for assignment. So that's why most other languages don't do that. Okay, but hopefully we'll deal with that also. Okay, now why are these called, why is this called an operator? Operator means that you have one thing on one side and something else on the other side, usually. Actually, that's called a binary operator because you have bi means two. You have one thing on the right side and one thing on the left side. But so that's an operator, I guess. The actual definition of what an operator is, we don't have to worry about. Multiple conditions. So we might want to say something like, if today is Monday or Tuesday, Professor Claster has a computer science class, right? So then we want to use something called or. So let's briefly talk about that or. I don't know if we talked about this before or not. Let's just briefly talk about or. Okay, so let's just explore this idea of and or. So the day that I'm actually recording this is Monday. Okay, today is a Monday actually. So anyway, so suppose that X stands for today is Monday, and Y stands for today we have computer class. So so suppose that it is true, X is true. Now suppose it actually is true that today is Monday, and suppose it is true that we actually have computer class. If I say to you that today is Monday and we have computer class, was I telling the truth or not? You would say, yeah, I'm telling the truth. So we put that statement would be true in that case. Okay, now that's the and. I was using the word and. I said today is Monday and today we have computer class. Suppose I'm still using the word and, but suppose it actually is Monday but we don't have class, but I use the word and. In other words, I say today is Monday and we have computer class. You would say, no, that's not true. That's false. Okay? On the other hand, suppose that today wasn't Monday, but we do have computer class today, whatever day it happens to be, and I say, today is Monday, I say X, today is Monday, and today we have computer class. That would be false, because it actually isn't Monday, so you wouldn't say that the statement, that we call it the compound statement, because I'm saying X and y. So that's called a compound statement. So you would say that's false. Of course, if they're both false, if it's not Monday and we don't have computer class, and I say today is Monday and we have computer class, that's obviously false. So when we use the connector and, then we get this pattern here where the only time that it's true is when both x and y are true. Now if we use the connector or, it's a different story, right? If it's true that today is Monday and it's true that we have computer class, and I say today is Monday or we have computer class, you wouldn't say that that's false. So we would say that it's true. Okay? And also, if today is Monday, but we actually don't have computer class, but I say today is Monday or we have computer class, then you would still say that's a true statement. And of course, if it's FT, that's also true. In fact, the only time that or is false is when both sides of the or are false. In other words, if today is not Monday and we don't have computer class, and I say today is Monday or we have computer class, if neither of those are true, then you would say that the statement that has the or in it is false. We use this so-called structure, or this statement. So we'll talk about that. Any questions about that? Okay, let's quickly, just before we go through the slides, let's look at the examples that we want. So here's one where we're going to put in a test score here, and then we're going to run it, and we're going to get the grade, which is either pass or fail. Okay, so just a simple code like that. But what kind of code do you think we're going to implement, or what kind of structure do you think we might want here? So look at it again. We're going to put in the test score, and then based on the test score, we're going to say either pass or fail. So what do you think we might be using here? What? If, right? If what? You know, depending on what the cutoff point is, right? So suppose the cutoff point is 60%. Then what would we say? If the grade is greater than 60, then pass, right? And then we could have another if statement. If the grade is less than 60, or less than or equal to 60, or whatever we want to say, then what? Then fail, right? In fact, that's what they have here, right? If the score is greater than or equal to 60, then pass. If the score is less than or equal to 60, then fail. Okay? So we're going to build this program. And then we're going to implement the same program using if-else instead of two if statements. Right? So here we had, can you see that we had two if statements here? If and if. If and if. So that's two statements, two if statements, okay? But then we're going to use if-else also. Now, what's the if, I mean, I think you can say it without thinking too hard about it. What's the if-else statement going to be? Except so we want to say if something, then something, else something. So what is that going to be for this grading? If what? Yeah, if the grade is greater than or equal to whatever the cutoff is, 60 say, what? Then, and then you have to write then what? Then pass, and then what? Else fail. Okay, so we can redo this program that way as well, right? So we can do it with two if statements, two separate if statements, or we can do it with one if-else statement. Everyone agree with that? Okay, so we're going to do those. And then we will use the alternative to that kind of, those words, instead of if, else, and if, then, and else, there's another way of writing it. It's called select case. So that's just another alternative way to say the same thing. So we'll learn how to do that. And now we have a different one. Oh, sorry. No, that's the same one. Okay, now we have another problem where we want to put in the grade. Okay? So if you're a teacher, which maybe you'll be sometime in your life, or maybe you won't be, doesn't matter, but then you might decide about cutoffs, right? What about, like, for example, what? What's the APU cutoff, by the way? What's the cutoff for A+? 90, so that's what this says, right? What's the cutoff for A, is that right? I thought it was 85. But anyway, suppose it's 980, so, okay, what's the cutoff for B? Okay, so we can have this, this kind of statement. Now here we're using if, else if, that's a variation of what we talked about. Okay, instead of just if else, there's another possibility you can say, which is else if. Okay? So we're doing that. If one thing, then we do this. Else if something else, then we do something else, and so on, right? We can just keep going. So that we can use that. I think you can see that we'll probably be able to use that to assign a grade, right? So we type in a grade here, and this will pop out the grade, right? I'm sorry, we type in a score here, and this will pop out the grade, right? Okay? Everyone get that idea? So we're going to want to do that, but he has two buttons here. One is called the if then else, so he's doing it this way, but we also have this other variation I call the select case way, and so we implement both of those. This one goes in this button, and this one goes in this button. Okay, so you can do it either way. Okay, just as an exercise to show that we can do both types of coding. We're going to put two buttons. You don't need two buttons. It's superfluous. It's redundant to have both buttons there. You don't need it, but just as an exercise, just to show that you know how to do it, we can have a separate button using the other structure called select case. Okay? Everyone get that? And then remember we did this last week. This was about variable scope. So let's just review that. Here I have a variable called, what's this one called? Last score. Here I have a variable called score. Here I have a variable called message. Here I have a variable called grade. Grade. Those are all the variables that are declared here. Now you might object and say this is not being declared, but I pointed out last time that you can declare a variable in this way instead of using the dim statement. Okay, so that's another way to declare a variable. So we have a bunch of variables declared here. Now, do you remember the problem that we had to solve here, the conceptual problem or the programming problem that was an issue here that we talked about last week? Remember, this is supposed to do what? If you remember the way this program worked, what did it do? Does anybody remember? So do you remember that it remembered what the last, so you put in a grade and it says, did you pass or not, right? But then you say, okay, now give the student a new grade. And then it says, did they pass or not? And it gives one more output besides that. Besides saying whether they passed or not, what was the other output? What? It said how much they increased by. But how did it know what the old grade was? That was our question. How did it know what the old grade was? Right? So how does it know what the old grade was? And the problem was that to know what the old grade was, it needed to store it in a variable. But the problem was that when it stores it in, if the variable was declared in this area here, then when the button click is finished, that variable disappears. The computer loses track of it, doesn't know where it is anymore. The number might still be stored in the memory, but the computer forgets about where it is. So basically we can just say it disappears. Okay, so that variable disappears, and so what? It doesn't know what the previous grade was. So if we declare a variable in here, inside the button code, inside the button click code, then that variable will disappear as soon as the button is basically clicked. So then any information we stored in there would be gone. So how do we solve that issue? How did we solve that issue? We declared a variable outside of the button click code, and that won't disappear when the button is clicked. So what we do down here is we take the score and we store it in this last score variable, which was declared outside of the button click code, right? So then that last score is holding the older score, right? So when we enter in a new score, it still knows what the older score is. And it can say, oh, you improved from, here it says, oh, you improved from last score to the current score. Okay, so that was the issue, and that was to illustrate to us this idea of variable scope. Variable scope means when a variable exists and when it dies. Okay, so when it exists is as long as this code is running, it exists, but it dies as soon as this code is gone. So the scope of a variable declared in here, we say, is just within this private sub here, or this button click handler code. Okay? And on the other hand, something out here will exist as long as the form is visible. By the way, when the form disappears, if we close the program or close the form, then that variable will also get lost. Okay? So the scope of this variable is the whole form, and the form is defined by what we call a class. So this is called class level variable. And this one are called local variables. Local variables mean they're defined within a function, or within a method, or within a sub-procedure. Okay? So this is called these are called local variables. And in fact, these, even though they are declared within the sub-procedure, are actually declared within an if-then-else clause. And so they're even sort of more local, and they're called block level. Okay? And we're going to discuss this again today. Okay, does everybody recall this issue though? Okay. So this is a continuation of that, and here. And then your last, your homework will be to redo your BMI calculator to deal with this. So if the person is under 18.5, we want to report underweight. If they're here, we want this. If they're here, we want this. If they're here, we want this. Okay? Everyone see? So that's gonna be your homework to re-implement this. And you're gonna use if then else and also select case. Okay? Any questions about the homework that's gonna be due? So, okay, with that in mind, let's go back to the beginning. Okay, any questions before we start? Okay, he says this. What does he mean by this? Given what we've just been talking about, given what I've spent the last 10 minutes talking about, what does he mean by this? So far, our programs have been rather linear. So what does he mean by that, given what we've just been saying? Huh? So there's like no decision structures, right? It just goes da 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 da, right? We do this, we do this, we do that, we do that, right? There's no decision structure. What he means is this. Now we have what? Now that we're talking about decision structure, we have this picture, right? If something is true, we go this way. If it's not true, we go this way. So this, he means, is not linear, whereas otherwise you just go da 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 da, right? So now with this if-then possibility, we can have this non-linear structure. Okay, so far our programs have been rather linear. Most have executed single path, unbranched computation. Okay, so you can imagine what we mean by unbranched, right? No decision node. Okay, so we get the input and we apply a single computation to do the output result and get an output result, right? However, most real algorithms involve decision making. Example, assign grades to students based on their scores. The ability to make decisions is called branching. Okay, it's called branching. Blocks of code for making decisions are called decision structures. So if we have a block of code that's used to make a decision or implement a decision, we'll call that decision structure. VB.NET provides several flavors for this. So they have just the plain if-then statement, they have the if-then-else statement, they have the select case statement, and there's one more that he's not mentioning here, which is what? We also saw, what was the other one? If, then, else if. Right? That's one more. Each of these provides a means to control program flow via evaluation of one or more test conditions. Let's take a look at the simplest, the if statement. Okay, so let's look at this. The simplest VB decision structure is the if, then, else statement. This allows conditional execution of a set of statements. Why do we call it conditional execution? Because it's based on the condition, right? If it's one condition, we go one way. If it's another condition, we go another way. So call that conditional execution of a set of statements based on satisfaction of a specific condition, right? If, the VB syntax, the way that we write it, in other words, for the if-then statement is like this. So this is how you write it in VB. So you have if, you have then, and you have end if. You have to put in the end if also. So you wouldn't, in regular English, we don't have to put in end if, right? I don't have to say, if today is Monday, then we have computer class end if, right? We don't speak like that. But in Visual Basic, you do. So the Visual Basic syntax for the if-then statement is what? You have if, you have then, and you also need the end if at the end. Now I think when you type if-then, the IntelliSense editor will automatically insert end if for you, but if it doesn't, you have to. Or, yeah. And then we have, between the if and the then keywords, we have to write the condition. Okay? You have to write the condition. And after the then statement, after the then keyword, we have to write what we want to happen. He says the statements to execute when the condition is met. Okay? Here, if is a VB keyword or reserved word, telling the computer to test for satisfaction of a condition. Note the condition may be composite. So what does that mean? Again, composite means we might have and or there, or some other weird combination of those. By the way, you can do that in Google. You can search with and or. I think. Yeah, I'm pretty sure you can. Okay? Okay, example, is x larger than 3? So, okay. Then is another Visual Basic keyword, telling the computer to execute the blocks statement. Example, add 5 to x. So if x is larger than 3, add 5 to x, or something like that. And if is a pair of VB keywords which tells the computer that the if-then block is over. Okay? Okay, understanding the syntax. in words, the if-then statement says, if the condition is true, then the statements following the then will be executed. Example, in words, if a student's score is 60 or higher, they pass the test. VB code, how do we write that? So we write if grade is greater than or equal to 60, then, and then evaluation equals pass, and end if. The if-then flow of control is shown more clearly by a flow chart. So you can see it. We enter here, and if the condition is true, we do this, and false, nothing, just do nothing. Okay, that's what this says. If this is true, then do this, and there's no else there, right? It doesn't say what to do if the condition is not true. Of course, we could write the else statement, but he didn't write such a statement here. Okay, so there's nothing. He just goes to the end. So if the condition is true, the statement in the block take effect. So this is called the block, or the statement in the block. This is called the statement in the block. The whole thing is called the block. Example, the student passes. Otherwise, the statements in the block are bypassed, and example, the student fails to pass. Well, it doesn't say that though. Okay? Any questions so far? Okay, so what's the code that will give us that? Okay, so write this up. So try this out for yourself in Visual Studio. Okay, try to make this yourself. And you will hand this in as part of your homework. Okay, so somebody mentioned something interesting. Wait, can I make this bigger? Which is, somebody mentioned something interesting, which is, look at these results here. If it's 59.5, it says what? And they tested it, and it was 59.5, it said pass, but if it was 59.4, it said fail. Now, what was their test? Here's the test. The condition was what? If it's greater than or equal to 60, so why did this pass? Why did this pass? Well, she said that this is declared, this is converted to a type integer, right? And what this will do is it will round it, okay? So if it's 0.5 or greater, it will round it up. If it's 0.5, or if it's less than 0.5, it will round it down. Okay, so, if you're, that could be very important under certain conditions, right? In certain situations. Okay, now next, what I want you to do is add in a second button here. Add in a second button, you can call it else run. Okay, add in another button called else run here. And before I say that, how many if statements did you write here in your code? 2, right? Okay, what I want you to do is put in a second button called else run. And in that button, I want you to have the same action, but I want you to use just one if statement, but I want you to you can use else. Okay, so you can write if, then, and then you can have another else. After what you have for then, you can have another else statement over here, and then write in some more code, and then the end if. So it should look like if, then, and then the stuff here, and then else, more stuff, and then then end if. Okay? So I want you to write another button. I don't care what you call the button, but you could call it else run. Okay, and it should have this in it, and see if you can get that to work. Okay, so let's look at that. So the else statement. Here's the else statement here. So what does it say? It's if there's a condition, then you have one set of statements. Else, so you're allowed to write else now, and then another set of statements, and then and if. And I'm saying that if you use this structure, you don't need to use two if statements to do the last program. Okay, let's see what he says. In the last example, we used two if-then blocks. The first tests whether the student passed and executes a pass statement. The second tests whether the student failed and executes a fail statement. This is rather redundant. Okay, the else statement allows binary selection of two processes, whatever that means. The then blocks statements are executed if the condition is met. Otherwise, a set of statements in an else block are executed. And this is the syntax. Means that's how you write it in Visual Basic. Okay, and this is the way it works. So if the condition is false, you do something. If the condition is true, you also do something. Remember the last one, if the condition was false, we didn't do anything. That's why we had to write two if-then statements. Right? Any question? Okay, the else-if statement. Okay, this one, you don't need to use this for that last button that we just tried, but here's the else-if statement. This idea may be generalized to the linear testing of any number of conditions. Using the else-if statement, note no space between else and if. The syntax for the if-then-else-if conditional structure is, so the syntax means how you write it, if condition 1, then you do something. Else if condition 2, then you do something else. And you can just keep going on, right? If else if condition 3, 4, 5, 10, 100, 1,000. Of course you wouldn't do that, but else. Finally, you can have a last else if you want. So if none of the other conditions were met, you could have like a final, well, I'll just do that kind of thing, right? Just in case nothing else is met, I'll do that. Okay, and then end if. Okay, everyone get it? Okay, and this one looks like this. He says here, note the exclusivity. Exactly one condition's block will execute. Thus, if two conditions are true, only the first will execute. Okay, what does he mean by that? Well, look at this. If condition 1 is true, then what happens? We go this way, right? Everyone agree? You see this? This is important. What happens if condition 2 is also true? If condition 1 is true and condition 2 is true, which statement or statements will run? Again, let me say it again. If this is true, we said that we're going to go this way, right? Now I'm saying, what if this is true and this is true? Which statements will get run? What? I can't hear you. Just statement 1, right? You see that? Even though this is true, right? Suppose this is true, this won't get run, right? So that's what he means. Note the exclusivity. Exactly one condition's block will execute. Thus, if two conditions test true, only the first will execute. Okay? Any question about that? So, and he says, an if then else if structure thus acts like n if then statements, right? So we can have, instead of n means like many, right? Some number of if then statements. So instead of having multiple if then statements, we can have a single if then else if statement, okay? That's the idea. Any question about that? Sequentially testing n minus 1 explicit conditions. What does that mean? Sequentially testing n minus 1 explicit conditions. Well, explicit just means he wrote them. Kind of don't need to write that word here. I don't think. And sorry, and one implicit condition, the default failure. Okay, I agree, I'm sorry. You could use the word explicit here. So, sequentially testing n minus 1 explicit conditions. Okay? So we're testing one after another, and finally we stop if one of them is true, otherwise we go all the way to the else statement and false. Any questions about this? So is this how you wrote your second button? Remember I asked you to put in a second button? Actually, he's putting it in the first button. But remember I asked you to make a second button and use, instead of two if statements, use an if-else statement, right? So this is what you should have done, right? If the score is greater than or equal to 60, something, and then you just write else, and then fail. Okay? So hopefully you did that correctly. Okay, any questions so far? Okay, the next thing is just another way of doing what we just did. Just another way of doing what we just did. So it's just another way of basically trying to decide, based on some condition, what to do, what code to follow. Right? You understand? And this one, this structure or statement is called the select case statement. And you can see it's written here. So, what was the name of the variable that we were looking at in the last code? What's the name of the test variable, so-called test variable, thing that we're testing? What was the name of the test variable? Score, right? That's what we were testing, right? So what we do when we do this select statement is, see, look, weren't we saying, okay, one thing about the select statement here, right here, is that the variable that you're testing has to be the same for each part. Now here, there were two parts, right? Do you see what I mean by part? There was this block and there was this block, right? And, but we were testing score in both of them, right? But you could, if I wrote else if here, or in fact, I'm sorry, yeah, if I wrote else if here, I wouldn't have to test score in this block. I could test something else. So I could say, if score is greater than this, then do this. Else if something else, I don't even have to be testing score, do something else. Do you understand? But you can't do that kind of thing in this next example. That you can only check one variable in this next example, okay? So let's see again. So here, you write the name of the variable. So what would I put in the last example here? What would go here? Score. Okay, so I'd write score, and then I'd write the first condition that I want to test. So what was the condition that I test? This is called the condition. So what was the first condition I wanted to test? Score is greater than or equal to 60, right? And what was the second condition I wanted to test? Well, it's not written here actually. But in the other if statement, it was explicitly written as what? If score is less than 60, right? So there was one condition and then another condition, right? So again, going back to here, what's the name of the variable?
Score.
Score. The first condition is what? So I write case instead of condition. I use case. Case, and what? What was the first condition? If score was greater than or equal to 60, right? And then you just say here what you want to happen. Okay, and then you can write case again. And what was the second condition we wanted to check? Whether, as we said, whether score is less than 60. So you write score here, and then you write greater than 60 here, and less than 60 here. Okay? Now, we just have to modify that just a little bit. We have to write case is, not just case. But I don't just write case, I have to write case is. Okay? Now, if it's, that's because the variable here, what's the variable again? Score, right? That variable is has a continuous range of values, right? What do I mean by continuous range of values? It's not just like score can be 1 or 2 or 3 or 4. It can be anything between 1 and 2. So it could be 1.55555, right? That's a continuous range of values. In that case, in that situation, you have to write case is here. Okay, that's just one thing you have to remember. Okay, does everyone know what I'm talking about? So in the case where we have a continuous range of values, which we do for score, because score can be like any kind of decimal point, any number of decimal digits. So in that case, we have to write case is here, not just case. Okay? Is that clear? If it's a discrete set of values, that means like just a not continuous set of values, then you can just write case. Okay? So again, this is an alternative to what? To the if, then, else if way of writing. And this can be kind of easier to write it sometimes, and also easier in a way to read it. Okay? Any questions so far? And what's the statement saying? Case else. So if none of these conditions are met, you can have like one kind of, we can call it like garbage collection case. So if nothing else happens, then just do a bunch of other things that you can say what to do. Okay? Understand? Any questions about this? Okay, so how can we rewrite our relatively simple program, which has this one back here, sorry. This one, which was the if-else, how can we rewrite that using case? So, I'll let you try. I'll let you struggle to do it yourself first, then we'll look at it. Okay? So, what we want is to rewrite that. So put in a third button, if you will. A third button. You can call it select case as the button. Okay? And try to use this explanation to implement the same action. Now remember, for when you're talking about score being a continuous variable, you have to change this not to case, but to case is. Okay, so let's see how this could be done. So here it is. Two versions. Maybe you didn't use this version because we didn't discuss it. But this version you might have used. So let's see it. We write the select case. We have to identify the variable that we're testing. And then we have to identify the different conditions on that variable. And in our example, there's only two conditions, two different possible conditions we want to evaluate. So the first is what? If score is what? You don't have to write score again here. Okay, so if score is what? greater than or equal to 60, in fact, you don't write score. You definitely don't want to put score there. So anyway, if it's greater than or equal to 60, that's one case. And what do we want to happen? This code we want to run. And then really there's nothing else, because we can just use the else to do the other one. We don't need to test any other special cases. Okay, this was a very simple implementation, so we didn't need a long list. Okay? Now there's another way we could do it using the case, and that's this. Now what's it? Okay, so this. What's the difference between this one and this one? So is the variable the same in the top example and the bottom? What's the difference? Is the variable the same? No? Variable's the same, right? What's the variable?
Score.
Score, right? Okay, so that part is the same. So, and by the way, the second part of the case implementation is also still the same, right? Case else, right? That's still the same. So what's the difference? The only difference is the way they wrote the condition, right? And well, sorry, not just that. Also, the word is here, but it's not here, right? Okay, that's one other difference. Okay? You see that? So what's the difference? This one is a continuous set of values, we say in mathematics, whereas this one is kind of like a discrete set. So you could write 60 to 100. That means if actually that's still kind of a continuous set, I think, but anyway, so 60 to 100, you could write that, okay? And then you don't need the is, all right? And that is described here, a discrete set of values. So, for example, if you're only looking at 1, 2, 3, 4, and 5, you could list those next to your case keyword, okay? Or so we could have written like 60, 61, 62, 60, but that wouldn't really be good, because how about if they got 61.4 or something like that, okay? But anyway, and you can also write it like this. Instead of writing out the numbers like this, you can write 1 to 5, okay? And I don't believe that, actually I have to admit I'm not sure, whether this and this are the same. I don't think so. I think this is everything. This is not, well, I'm not sure. I have to check that. I'm not sure whether this is only testing for the integers between 1 and 5. I don't think so. Okay? Because look at this example. Score doesn't have to be an integer. Oh, but it is converted to an integer. So I'm not sure about that. Okay? Excuse me for not knowing that. We'll have to check that a little later. Any questions so far? Okay. Now we go to the comparison operators, and those are equals is one of them, and these are this is the entire list. So we talked about this one, right? Greater than or equal to, or did we talk about that one? I forget. This is less than, this is greater than. This one is what? Not equal to, or inequality. And this is equals. Okay, these are called comparison operators. And we often want to check. In fact, we just had to use this one, right? We just used this one. These are the other ones that you can use. Okay? So each compares two operands. What's an operand? Just the thing on either side of the operator. So like we did here. Well, let's say this one. Score and this, right? So these are called the two operands. Okay? Even in the case statement, it's still the same. But score is written up here instead of here. Okay? But it's still the same thing. Okay, let's read what he says. Comparison operators. A comparison operator compares two operands. one on the right side and one on the left side of the operator. Thus, a comparison has the general form, one on the left and one on the right, and you have the operator in the middle, and returns a logical value. When I say x is greater than, when I say this, when I say 3 is less than 2, you could say that that returns a value. And the value that it returns is either true or false. So what value does this return? 3, what does 3 is less than 2 return? Returns the value false. So what it means is that if you write, if 3 is less than 2, then, add 5 to age, or something like that. Okay? Whatever. Okay, suppose you have that statement. Are we going to add 5 to age? Are we? No, because this evaluates to true or false. Which one? To false. So then what's in here is false. Okay? So we say that it returns a logical value. Logical value, remember, means something means either true or false. Those are the only two values. Like if something's an integer, you have so many different possibilities. But if something is a Boolean, or in other words, a logical variable, that means it only has two possible values, just true or false. Okay? So, returns a logical value based on whether the comparison is true or false. Example, the equality operator compares operands and returns true if they are equal and false if they are not. So if x equals 5, then do this. So here, x equals 5 evaluates to true. I don't know why it says that. If x is equal to 5, in which case statement 1 will be executed, but evaluates to false if not. Any questions about that? Okay, of course you all understand this, but you have to get the language here that we're using, right? So the language like logical value and things like that, right? You need to get used to that. Whoever is mumbling, whoever's talking, can the TA make sure that we get quiet in the room? Okay, so here it is. So we have that. Okay, any questions? These are the logical operators. I'm sorry, the comparison operators. Okay, now here we have what I mentioned before, but let's quickly review it. So here we have A and B, A or B, and this is a different one. We'll talk about that in a second. Okay, so what did we say? If both A is false and B is false, then what about A and B? It's also false, right? Right? For example, if I say today I'm living on the moon, and today I am Donald Duck, today I'm living on the moon, and I am Donald Duck. Those are both false. What would you say about the composite or compound statement? False, right? And so on. If the first one is false and the second one is true, and I say and, it's false. So on. The only time that it was true was if they were both true. The only time this was true was when they were both true. If it's or, the only time it's false is if they're both false. And this is called the exclusive or, and that means, remember, I think I mentioned this before, but suppose I tell my son, if you go to the movie, you can go to the movies or you can go to the amusement park, right? And suppose he does both of them. Should I say he didn't follow my instructions? No, in normal English I couldn't say that. But if I use the exclusive or, which no one ever says, you can go to the movies exclusive or you can go to the amusement park, we don't say it, we never would say that. But if I did say that, then, in that case, if he went to both, he would not be following my instructions. Okay, so that's the exclusive or. So, in other words, for the exclusive or, if they're both true, then the exclusive or is false. Okay, so if he does both, then he didn't follow my instructions. Okay, is that clear? Sort of? Okay. So sometimes in English we can't really say that. I'd have to make a longer sentence, like say, you can go to the movies or you can go to the amusement park, but you can't do both. Okay, that would be the same thing as saying the exclusive or. Okay? All right, so we have and, or, exclusive or, and not, and not. We already talked about not. Okay, any question? Okay, so here we want to write a program which will do this. So what kind of structure do we want here? We could use many if-then statements, right? So we could have score, and we could say what? If score is between, or how about, yeah. If we did that, how would we implement the first A plus part? How would we implement that? If score what? How would we do that? We can't write in Visual Basic, you can't write score is between. You know how you write between in math, right? Score is less than A and greater than B or something like that, right? You can't write, in math you can write that in a single line. You can't do that. How do you do between in Visual Basic? What? And. Right? So what would I say? If score is less than or equal to 100, and capital A and D, by the way, capital A and D, and greater than or equal to, or whatever it is, greater than 90. Okay, or something like that. Depends how you want to code it, how you want, if you're the teacher, how you want to grade it. How you want to set it up. But anyway, okay? So you'd have to use and. Okay? So if you're going to use multiple if-then statements, that was the first way we did all of these exercises. You're going to have a bunch of them. And you could do it with and many times. How about if you wanted to do if, then, else, if, then, else, if. Still, you're going to need and, right? Okay? Still going to need and. Or we have a third alternative, which is what? Use the select case way of doing it, right? Select case structure. What's the test variable going to be? The same one that we used before, right? Which was what? Score. And then we have these different cases. So I think in this case, we're going to need the case is format, right, or syntax. We're going to need the case is syntax. And what should be the first case? First case is. I think we could just say score is, case is, and then score greater than or equal to, or maybe it should just be greater than, we'll see what he does in a minute. Let's say greater than or equal to 90. Okay, you understand? Then what will go next? Then we'll say, give A plus, right? And then we'll do another case. Case is, is that case is? No, it's not cases, it's just case. Just case. Case, what? Score. No, we don't need score. we just write greater than, or whatever it is, greater than or equal to 80, right? And then we'll say, okay, give them a or something, right? And then what would be the next line? Case, not cases, right? I made a mistake. It's just case greater than 70, and then we'll give them a B or something, right? Okay? So we don't need and in that case, using case. Using select case, we don't need and, it looks like, right? Okay, but in the other forms, in the other implementations, we need and. Maybe not. Let's see. Okay, let's see how it was done. He didn't use and. Okay? So you can do it the same way we did case. Now, whether we do it this way or whether we use the select case, remember what he said about exclusivity. Let's go back to that screen. Okay, what does he say about exclusivity here at the bottom of the screen? Note the exclusivity. Exactly one conditions block will execute. What does he mean? If this one happens, we ignore all the others, all the ones after that. Okay? All right? So the same thing here. So we can say just like this, score is greater than or equal to 90. If that happens, where do we go to in this picture, in this set of code? If this is greater than or equal to 90, where do we go? Do I check these? Do I check this? Do I check this? No, I don't have to check anything else. Okay, if this is true, I do this, and then where do I go? I go all the way to end if. Or I can say I jump out of the if block. Okay? How about if this one is not true, then where do I go? Here. Okay? Suppose this one is true, then where do I go? I do this, and then what do? I jump out again. I go to the end if. In other words, I jump out of the if-then block. Okay? Does everyone get it? The same thing is true with the case. So if this is true, where do I go? Out. By the way, it ends with end select. Okay? If this is not true, then where do I go? Here. Okay? If this is true, where do I go? I do what it says here, and then where do I go? I go out here, right? I jump out again. Okay? Finally, we usually want to have something, an else case, just what to do in case all the other stuff is not implemented. Okay? Or, I'm sorry, in case none of the others are implemented. Okay, is this clear? Okay? So we could write the greater like this. Right? Does everyone get it? Okay. All right, let's go back to this one. How much time do we have? What time is it? Anybody? I don't want to. What? 48? Oh, okay. Let's look at this. Okay, we looked at this before, right? I talked about it already today, in fact. This was the same thing with the last score being remembered from the previous, even though the button has finished running, right? Now, what he does here is he kind of makes this more clear by talking about trying to use a variable when it's outside of where it's visible. So if you try to use grade, if you try and talk about, okay, you could say, well, I declared grade here, right? Everyone see what I'm talking about? I declared grade here, so I can use it, right? Why not? So I start to use it up here somewhere, or say outside of even this block, actually. Okay? So I start to use it down here. What you're going to get is an error. Now the error is not going to be so clear because it's just going to not recognize the variable, so it doesn't know that it was sort of out of scope or something like that, right? It just can't find that variable, period. But do you understand? If you try and use a variable out here, you're going to get an error. Okay, if it was declared in here. The same thing here. How about this variable called score? If I try and use that outside of this button, it's also going to give me an error. Like maybe I have another code somewhere in this whole form, and I want to use score. I can't do it. It was only declared inside this method, inside this code, inside this sub-procedure. Okay? So he's going to try and illustrate that. And then one other thing is, when conflicts arise, the most local scope wins. What he means by conflict arises is suppose I declare score out here and in here. Which, of course, I could declare score out here as well as here. Suppose I declared score out here and set it equal to 10, and I declared score in here, and suppose I didn't do it like this, I just set it equal to 5. Okay? So score is defined as 5 here and 10 out here. Okay, he refers to that as a conflict. Okay, the question is, what will score equal? He says, when conflicts arise, the most local scope wins. Okay? So what does that mean? That means if I want to check what score is in here, it's not going to be 10. It's going to be 5. Okay? However, what happens if I check what score is out here? You might wonder that. What's going to happen if I check what score is out here? So the answer to that is, the score that we set it to 5 in here, right? That doesn't exist anymore, or may not exist. Okay? Okay, so then what? Score will be 10 out here still, if I refer to it outside of this button. Okay, when conflicts arise, the most local scope wins. If 2 or more variables are accessible with the same name but different scopes, the most local one is accessed. So if I access score in here, the most local is in here. So it'll be, what did I say, 5 in here? It'll be 5 in here. Okay? Let's examine the rules from a block perspective. First of all, variables declared inside a block are not visible outside of the block. So like I said, here, now this is even just in a block, I'm not talking about where the scope is the whole subroutine here, but if it's just declared in a block, this block here, so here dim is declared and set equal to 1. Then you might say, oh, I declare a new variable j and set it equal to that variable, this I here, right? Say, why not? Why can't I do this? Right? I can do that, but no, you can't, because this I doesn't exist outside of this block. Okay? So, first of all, variables declared inside a block are not visible outside the block. So here we get an error when we try to access I. Why? Because this is not the best example. I would have just, well, anyway, okay. Why? Because I only exists inside the if-then block. Okay, let's go on. Variable scope and blocks conflicts. Let's consider a conflict. Below we have 2 variables called I. Here's a variable called I. It's not in the subroutine. And here's a variable called I declared inside the subroutine. Okay? And now we have a message box, which is just going to print out what I is. And by the way, this plus might be confusing, but remember last time we said that you can use plus or you can use ampersand. Okay? So this is just like ampersand. Okay, it's just concatenation. Okay, so anyway, here we're going to basically just use this to see what the value is of I when we access it within this block. And here we're going to see what the value of I is when we access it outside of that block. Okay? Now, I was declared both inside the block and outside the block. Okay, so there's so you're allowed to access it in both places. Okay? But what does it equal inside the block? So we say there's a conflict here. So when you do this, what is it going to be? 0, right? It's going to be 0 because that's the value inside the block. But here, what's it going to be? It's going to be 1. So he says variable scopes and blocks conflicts. Let's consider conflict. Below, we have 2 variables called I. So you might say, wait a second, we have only 1 variable. You might say we have only 1 variable, but no, it's not. We have 2 separate variables called I. Okay, they're stored in different places. A class level variable named I, out here, and a block level also named I, inside of class level I scope. Inside the block, both of them exist. Okay, that's another thing. Inside the block, both of them exist, but which one is displayed? The local scope takes precedence over the less local scope. So which is the local scope? Inside. So what's the value going to be inside? This one here. Okay? Okay? Answer. When conflicts arise, the most local variable wins. In the block, local, I hides, sometimes you'll see this word, hides the value of the class level 1. Okay, so it takes over the value of the class level 1. Outside the block, only class level I exists. That's supposed to be small I. Exists, so it is displayed. Okay, does everyone get it? Note in VB, now he means VB as opposed to visualbasic.net. So in VB, method and block level variables with overlapping scope cannot be assigned the same name. So in Visual Basic we can do this. In visualbasic.net we can do this, but in VB you couldn't even do this. Okay? Okay, and then this is your additional homework. Okay? So you need to hand in all the projects we did today, plus this one for homework. Okay? So you're just going to be using select case and if then else.